This is the story of why the modern capybara, the internet's favorite gentle giant, represents a scaled-down version of what its prehistoric relatives once became. The animal you see today is the largest living rodent on Earth, topping out around 200 pounds and living in calm social groups along South American riverbanks. Yet tens of millions of years ago, its closest cousins tipped the scales at over a ton, carried incisors longer than your forearm, and generated a bite force in the same range as a modern tiger. In this video, we are going to trace how that happened, why those giants disappeared, and what the capybara's unusual family tree reveals about the history of life on Earth. If you enjoy deep dives into natural history, subscribe and leave a like, because that simple action helps more people find the channel and we genuinely read every comment. Hydrochoerus hydrochaeris, the modern capybara, holds the title of largest rodent alive today, with most adults weighing between 77 and 146 pounds and a few confirmed individuals reaching roughly 200. Standing about 2 feet tall at the shoulder and stretching 3 to 4 feet in length, this semi-aquatic herbivore spends much of its life in rivers, swamps, and wetlands across South America, from Venezuela and Brazil down to Argentina and Colombia. Partially webbed feet push it cleanly through the water. Grasses and aquatic plants make up most of its diet, along with fruit and bark, and social groups usually number 10 to 20 animals, though in rare cases they gather in herds approaching 100. Jaguars, anacondas, caimans, pumas, and ocelots all prey on them, which means a wild capybara typically lives 6 to 10 years if it avoids becoming a meal. The International Union for Conservation of Nature lists the species as least concern, and in Venezuela, people have farmed capybaras for meat for generations, with the Catholic Church even classifying them as fish for Lent so they could be eaten during fasting periods. By any normal standard, this animal counts as large and successful. That definition of large starts to shift once you look backward in time. If this is holding your attention, tap the like button because it takes 2 seconds and helps the channel more than you might think. To understand how capybara relatives reached such extreme sizes, you have to picture South America between 30 and 35 million years ago, cut off from North America by open ocean and evolving in isolation. That separation changed everything, because without the large herbivores that dominated other continents, the animals already living there expanded into roles that would normally belong to much bigger species. Ecological release set the stage, and caviomorph rodents, whose ancestors likely rafted across the South Atlantic from Africa between 35 and 41 million years ago on floating mats of vegetation, found themselves in a land full of opportunity. Once established, certain lineages began increasing in size over millions of years, eventually reaching proportions that sound implausible for members of the rodent order. No competing bison, no deer herds, no elephants roaming the same ground, which meant these rodents filled those spaces instead. The result was a collection of giant herbivores that had no modern equivalent, shaped by a continent running its own evolutionary experiment for tens of millions of uninterrupted years. That long isolation created giants, and it set the context for everything that followed. Around 6 to 8 million years ago, in what is now Venezuela, during the late Miocene, a rodent called Phoberomys pattersoni moved through wetlands that also supported giant crocodilians and large predatory birds. In September 2003, a team led by Marcelo Sanchez Villacra formally described it in the journal Science, and headlines quickly labeled it the guinea pig the size of a buffalo. Estimates placed its weight at roughly 700 kilograms, about 1,500 pounds, with a body length near 3 meters, including the tail, and teeth built for grinding grasses and aquatic plants rather than tearing flesh. Belonging to the extinct family Neoepiblemidae, Phoberomys stood as a distant relative of the modern capybara rather than a direct ancestor, yet it shared the same broader caviomorph roots. Despite that bulk, it did not sit at the top of the food chain. Giant crocodilians and formidable birds still posed a threat, which meant this animal lived as prey, just prey that demanded serious effort to subdue. The 2003 discovery confirmed how far rodent gigantism had gone in South America, and that finding forced researchers to reconsider what a rodent could become under the right conditions. January 16, 2008 marked the formal introduction of Joseph Artigasia Monesi in the Proceedings of the Royal Society Bay, described by Andres Rinderknecht and R. Ernesto Blanco from fossils recovered in Uruguay's San Jose Formation. Dating to the Pliocene between 2 and 4 million years ago, this animal holds the record as the largest rodent known to science. Everything hinges on a single skull measuring about 53 centimeters, roughly 21 inches long. And from that one specimen, researchers estimated a body mass near 1,000 kilograms or 2,200 pounds, with upper bound models pushing the figure even higher depending on assumptions. The name honors José Artigas and the paleontologist Álvaro Moniz, and taxonomically it falls within the family Dinomyidae, making it a cousin of the capybara rather than a direct ancestor. Its incisors, if fully extended, would have exceeded 30 centimeters in length, longer than a standard school ruler, and the 2008 paper calculated a normal bite force around 1,389 newtons, rising toward 3,000 newtons when neck muscles engaged. That range sits in the same territory as a modern tiger's bite. Researchers did not portray it as a predator. Instead, those enormous teeth likely served for defense against Pliocene predators, for digging, and for cracking hard-shelled fruits that smaller animals could not handle, which fits the broader pattern of giant South American rodents growing bigger and stronger to survive in ecosystems filled with serious threats. Size here looks less like aggression and more like armor. Closer to the modern capybara's own branch sits the genus Neocoerus, part of the same subfamily, Hydrocoerinae, and far more directly related than either Phoberomys or Josepho Artigasia. During the Pleistocene, which stretched from about 2.6 million years ago until roughly 11,700 years ago, these animals roamed a much broader territory than their living relatives. Estimates place their weight in the range of 100 to 150 kilograms or more, depending on species, making them larger than today's capybaras. And fossils of Neocoerus aesopii and Neocoerus pinckney I have turned up not only in South America, but also in Florida, Texas, and Mexico. That northern expansion became possible around 3 million years ago when the Isthmus of Panama formed, linking North and South America in what scientists call the Great American Biotic Interchange. Animals moved in both directions across that land bridge, capybara relatives among them, which meant true members of the capybara lineage once occupied parts of the southern United States. The modern species now lives exclusively in South America. The range shrank, and the giants eventually vanished. Phoberomys disappeared millions of years before the end of the Ice Age, and Joseph Artigasia vanished during the Pliocene, long before humans entered the picture in large numbers. Their decline ties into sweeping ecological changes, including the arrival of new predators and competitors after the land bridge formed about 3 million years ago. The Great American Biotic Interchange reshaped both continents, sending North American predators south and disrupting the balance that had allowed oversized rodents to thrive for so long. Neocoerus and many other large mammals survived into the Pleistocene, but around 11,700 years ago, a global megafauna extinction event swept them away. Climate shifts at the close of the last ice age, combined with hunting pressure from expanding human populations, and for most species the likely explanation involves both forces acting together. when the dust settled, the giant caviomorph rodents were gone. What remained was a smaller descendant. Today only Hydrochoerus hydrochaeris and its close relative Hydrochoerus isthmius, the lesser capybara of Panama and Colombia, carry forward this once expansive lineage. Everything else in that oversized branch of the rodent family tree has disappeared, continuously growing incisors, reinforced with iron compounds, keep their cutting edges sharp as they wear down. Partially webbed feet support a semi-aquatic lifestyle, and social behavior helps groups detect predators and share resources. A smaller body also demands fewer calories, which offers an advantage when environments shift and food becomes less predictable. The giants belonged to a world defined by long isolation and ecological freedom, and once that isolation ended, the conditions that supported such massive rodents faded with them. What survives is still the largest rodent on Earth. Seen in that light, the modern capybara carries the quiet echo of a far more imposing past. That is the story of why prehistoric capybara relatives grew so much larger and more formidable than the peaceful animal we know today. If you enjoyed this deep dive into natural history, subscribe for more explorations of the animals that shaped life on Earth, and leave a comment with the topic you would like covered next, because your suggestions genuinely influence what comes next on this channel.